In this video, we're going to see how to convert our mixed radicals back into entire radicals. Okay, so in previous videos, we have learned how to simplify radicals into mixed radicals. Now we're going to learn how to go the other way. And this is very, very easy. This is the easiest part of this lesson. So when you see a mixed radical, which means if you see the one with a number outside, a coefficient and a radical part, but you want to take everything back inside, like in this example, what we do over here is just pay attention to the index. So the index is here is 2. That means this 4 will go in there and multiply by itself twice. Or what I like to write it is this way. It just gets squared. And it multiplies with what is already inside, the 5. So 5 was already in there. I took 4 back in there. And because I'm taking it back in there, I follow what the index was. It got square rooted to come out. So it has to get squared to go back inside. So the 4 got squared, which is 16. So what does that give us? We have 16 times 5, that is 80. So now a mixed radical, which had a coefficient in front, went back inside and it ended up becoming 80. What happens if you have the same question, but if it was a cube root, let's say? So what if this question was cube root 5? This 4 has to go inside now, but because the index is 3, it will get cubed. It will multiply itself 3 times and then multiply by the 5. Don't change the 5. It's already in there. It's not coming back inside. So we don't do anything with the 5, only with the number that is coming inside. So you're going to go 4 times 4 times 4, which is 64. And the 5 that was already in there gets multiplied to it, and then this number ends up becoming 320. So anytime you see a mixed radical going back into the entire radical form, just follow the index, and the number that's going inside has to get squared or cubed or to that power. Okay? Like in this example here, 2 is going to get squared inside. I'm not going to finish this question, but just to go over that point, don't do anything to the 6. 6 is already there. What do we do if there's a negative outside? My suggestion is always leave the negative out. Just keep it out and only take the number inside. And as you square it, so this will end up becoming 25 times 7, and that ends up becoming 25 times 7. Can't do that in my head. It's 175. So if the negative is outside, leave it outside. Because if you do take it inside, it will end up becoming positive, and a negative number will end up becoming positive. This is what I mean. If you take that negative 5 inside and square it, it ends up becoming 25, and then it ends up becoming a positive number. So my suggestion, and that will be really good for a lot of questions that you're going to see, always try to bring the negative out, and if there's a negative outside, leave it out. What do we do with fractions? The same thing. You take the fraction inside, and the whole fraction will follow the index, which is 2. Now, in this case, this becomes more of your fraction skills than anything else. So recognize that you have this becomes 4 over 9. But what I like to always tell students is that if there's a whole number next to your fraction, think about what its denominator is. Every whole number has a denominator 1. And this is very important to put that in there, because a lot of people make mistakes. They multiply this number inside with both numerator and denominator. So once you see it this way, You can do this question many different ways. One way that students like to do this is by multiplying the numerator by numerator, the denominator by denominator, and then reducing it, which in this case becomes 8. Other students like to simplify before they multiply, and that is okay too. But these are both acceptable ways, and in the end you will get the answer to be 8. So whether it is a number, a fraction, just take a look at what the index is and then just take it to that power and then work it through. I know it looks different because we started with a fraction and we ended up with a whole number. The value of them is the same. If you were to put this in the calculator and put this in the calculator, you will get the exact same decimal answer. That's how we know we have the same answer. Now you will see questions in here, like example number 7 in your book, which says, without using a calculator, arrange these mixed numbers from the greatest to least. You could definitely change them all back into entire radicals and then see which one is the biggest and which is the smallest. Or you can put them in the calculator, get their decimal equivalent, and then find out which is the greatest to the least. And once again, please go into your Moodle in the lessons, go through the enhanced lessons to make sure you're doing the rest of these examples and you're able to finish the homework from this section.